Welcome back. Today we're going to be talking about molecules that come from the Earth that are important. So we're not talking about elements anymore. We're not talking about things that we mine and purify. We're talking about actually molecules now, combinations of atoms that are important to us, and we're going to talk about how they're fundamentally bound together. So let me tell you a couple of stories of chemical discoveries. And I'm going to start by talking about a pigment. So 4 boys and a dog, the dog was named as Robot, went on an expedition in September of 1940. And this is during the Second World War. The Germans had invaded France, and they had stopped a few miles north of the boys' village. So Marcel Rabideau had discovered a hole under a tree with his friends, and he descended 40 feet down into a large cavern. And this limestone cavern had animals actually painted in bold red, yellow colors, brown, black, and in fact this dated to 17,000 years ago, the end of the Ice Age. And when people later on did an analysis of the black outlines that they had seen on the limestone walls, that they showed they weren't charcoal, they weren't just carbon, but instead manganese black. Manganese black is manganese oxide, and so that's Mg, I'm sorry, MnO, and this is found in ore 150 miles away. So this is a pretty amazing discovery in the sense that 17,000 years ago, people apparently had a pretty elaborate trading system for different kinds of pigments that they were utilizing for drawing, and we were able to discover it to this day. Okay, so another interesting mineral that comes from the Earth that was important to us comes to us really all over the planet, but the story comes to us from the Tiwi Islands, which is off the northern tip of Australia. There are a few thousand Tiwis, that's Tiwi, and it means we the only people. And over the years, the Tiwis established what was effectively rules to prevent inbreeding, because there were only a certain amount of them on an island. And so children would be painted with body paint, red as the sun, or black as stone, white as these pandera bushes, and yellow as fish. And to prevent the inbreeding, they had these cultural rules. So reds cannot marry yellows or whites, and then whites cannot marry reds, and so on and so forth. The interesting thing is that, of course, these colors, once again, these colors are made from the earth. They're pigments, and the reds in particular, the reds and the yellows, are pigments of iron oxides. And in fact, the Australian Aboriginal people's painting tradition dates over 40,000 years ago. So these are important molecules to people. Even more amazingly, red ochre, which is iron oxide, was discovered by archaeologists in a painting kit found in a cave in South Africa. And it is found in an abalone shell as a pallet bowl, and the red-yellow ochre residues were found in this shell. There was a bone spatula, bricks of red ochre, and they actually dated these to about 80,000 years ago. So our species has been utilizing pigments from the earth for forms of painting for a variety of different reasons since basically almost the beginning of our existence. Okay, so lastly, as a mineral from the earth that's been historically quite important for us, sodium chloride. This is table salt, and really, as far back as 6050 BC, salt has been identified as an integral part of the world's history. It's an essential part of human, animal, and plant diets, and it's actually it's a crucial molecule economically. So the phrase "not worth his salt" was actually a Greek term about trading slaves. Slaves were traded for salt, And the question might be perhaps why was salt so important for so long? Why were civilizations built on the ability to get salt? Well, of course, refrigeration is a relatively new thing. So salt helped dry out and preserve a lot of food so that it wouldn't spoil. And in fact, jerkies were a really common way to preserve meats that would go rancid quite quickly, and it'd be quite a waste of food, or potentially the ability to get to pass on disease if you couldn't preserve food with salt. Okay, so in all of these cases, in the manganese oxide that found in the pigment in the cave, in the red ochre that was found in the bowl or on the Tiwis who painted themselves, or the salt, the sodium chloride that was used to preserve food and for nutrition for thousands of years. All of these are now molecules. They're held together via chemical bonds. So there's a force that's holding atoms together. In this class, we're going to talk about two different kinds of bonds: ionic bonds and covalent bonds. In this particular chapter, we're going to be referring and talking about ionic bonds, and this is going to be formed between a metal, so something over here, and something over here. So when we talk about sodium chloride, we're talking about a metal mixing with a nonmetal. Or we're talking about red ochre, iron oxide, we're talking about a metal mixing with a nonmetal. And so these are held together via ionic bonds. And in this case, what we're really doing is we are formally gaining or losing electrons, and this process creates charge in our molecules, and just kind of like magnets, the positive and negative charges is sticking to one another. They're being attracted to one another. So let's learn some more about these attractive forces and how we can make molecules out of simply ionizing atoms.